Bismillahirrahmanirrahim. This is the part 3 of topical question paper solution, and the topic is DC circuits. Course is Cambridge O level physics. Course code is 5054. Let's start our session. We will solve 10 questions in this session. Okay, question number 1. The currents in different parts of the circuits are I1, I2, I3 and I4. Which statement is correct? So you can see I1 is equal to I4. These are the total current coming from the battery and going back to the battery, whereas I2 and I3 are the branch currents. I3 is greater than I2 because I3 is flowing through the minimum resistance branch, that is in 5 ohm, and the value of I2 is less than I3 because it is flowing through 10 ohm branch, whereas I1 is equal to I4. So option B, I1 is equal to I4 and I3 is greater than I2. So some explanation I can read for you. I1 is equal to I4 because both are same full currents coming from the battery. I1 is coming from the battery, it is conventional current, and I4 is going back to the battery. It is also a conventional current coming from the positive plate of the battery and going back to the negative plate. Full current coming from the battery will be divided into parallel branches as follows. I1 is equal to I4 and that is equal to I2 plus I3. I2 and I3 are parts, whereas I1 and I4 are whole currents, full currents. And 5 ohm is the parallel branch with least resistance. So largest current will flow through this parallel branch, that is will flow through 5 ohm. 10 ohm is the parallel branch with the largest resistance, so lesser current will flow through it. So I3 is greater than I2. I2 is missing. I3 is the current flowing in the 5 ohm branch, and I2 is the current flowing in the 10 ohm branch. So I3 is greater than I2. So you again, the question diagram, I1 is equal to I4 and I3 is greater than I2 because I3 sees the resistance of only 5 ohm, whereas I2 sees the resistance of 10 ohm. Okay. Next question is question number 2. An emitter is connected to 3 resistors and a power supply. Which arrangement of resistors gives the greatest ammeter reading? So in option A, you can see 3 resistors in series, and in option B, there is a series parallel combination. In option C, there is also a series parallel combination. In option D, there is a parallel combination. So remember the rule of thumbs. The current will be highest in parallel combination. Okay, this is one extreme condition, and the current will be lowest in series connection of resistors. It's another extreme condition. Whereas all other series parallel combinations will have the amount of current in between these two extreme conditions. So the highest current will flow through the option D. The lowest current will flow through a series combination as the effective resistance is the highest in series combination. The highest current will flow through the parallel combination as the effective resistance is the lowest in parallel combination. The effective resistances and the resulting currents for all other series parallel combinations fall in between these two extreme conditions. The greater ammeter reading is therefore in option D. that is in parallel circuit. Question number 3. A cell is connected in series with an ammeter and a lamp. The reading on the ammeter is 1 ampere. In which circuit using identical lamps, ammeters and cells is the reading on the ammeter 2 ampere? In option A, the ammeter will read 1 ampere because two cells are connected in parallel, so the effective voltage is the same as that of a single cell, and there is only one lamp, so it is 1 ampere flowing through the lamp. In option B, again 1 ampere will flow through these two lamps because the batteries are connected in series configurations and the amount of the voltage is doubled, but the resistance offered by two lamps is also doubled, so 1 ampere will continue to flow in uh, B configuration. Okay, in C configuration, 0.5 ampere will flow in the circuit because two lamps are connected to a battery, so resistance double and the current will be half. And in D configuration, 2 ampere will current flow, 1 ampere through one parallel branch and another 1 ampere through another parallel branch, and the ammeter will measure or record 1 plus 1 is equal to 2 ampere, or in other words, the effective resistance of these two bulbs will become one half, and as the effective resistance has become one half, so the amount of current will become double, so it is 2 ampere in option D. Question number 4. In the circuits P and Q below, resistors R1, R2 and R3 have different resistances. In which circuit are the currents in the resistors equal? And in which circuit are the potential differences across the resistors equal? All the resistors have different resistances. So current is same in the series combination. In circuit Q is the series combination of three resistors. Recording their values, same amount of current will flow in these three resistors. Whereas the voltage is same for all the elements connected in parallel, as you can see in circuit P. Three unequal resistors are connected in parallel, but the voltage will remain the same across them in circuit P. So currents are equal in circuit Q and the voltages are equal in circuit P. It is option C. So current is same through every element in series combination, and voltage across every element is same in parallel combination. So it is option C. Question number 5. The circuit shows three resistors connected to a cell. The resistors have different values of resistance. V1 and V2 are potential differences and I1 and I2 are currents as shown. Which pair of relationships is correct? It is option C. I1 not equal to I2 and V1 is equal to V2. Why I1 not equal to I2? Because the resistances values are different. And why V1 is equal to V2? Because the voltage is same across the elements in connected in parallel configuration. So option C, V1 is equal to V2 and I1 not equal to I2 is the correct option. V1 is equal to V2 because voltage across the elements connected in parallel configuration is same. And I1 not equal to I2 because the resistors connected in parallel are of different values. Question number 6. The diagram shows a circuit containing 5 resistors connected to a battery. In which resistor is the current the smallest? Current is highest at point A. It is the full current coming from the battery, and then it will divide itself in first parallel branch, that is among 10 ohm and 30 ohm, and 25% of the current, total current, will flow through C, and 75% of the total current will flow through B, because 30 is uh, 3 times more than the 10 ohm resistor. And in second parallel configuration, half of the current, that is 50% of the total current, will flow through 40 ohm through D point. So the minimum current, that is 25% of the total current, will flow through the point C, that is through 30 ohm resistor. So total current passes through 50 ohm, is passing through point A, and that current will divide in two parallel branches. 25% of the total current will flow through 30 ohm. 30 ohm is at point C, and 75% of the total current will flow through 10 ohm at point B. The 50% of the total current will flow through 40 ohm at point D. So the smallest current will flow through C, where 30 ohm is connected. Remember one thing, total current is coming from the battery, and the current flowing in parallel branch C as a fraction of total current IT is given as. So this is the formula for the branch current flowing in C branch. IC is equal to 10 over 10 plus 30. 10 is the value of the resistance in the second branch, and divided by the total amount of resistance and multiply with the total current. So it is IT by 4. So 1/4 of the current is flowing through C, and 3 quarters of the current is flowing through B, and 100% current is flowing through A, and 50% current is flowing through D. So the correct option is option C. Question number 7. The diagram shows an ammeter connected in a circuit. What is the current in the ammeter? From Ohm's law, I is equal to V over R. So it is 10 volt over 2 kilo ohm, and it is equal to 5 milliampere. Option A. Question number 8. In the circuit shown, the potential difference across the 4 ohm resistor is 8 volt. What is the potential difference across the 2 ohm resistor? It is a simple voltage divider circuit. Total voltage is 12 volt, and out of 12 volt, 8 volt is dropped across 4, and the remaining 4 volt, 12 minus 8 is equal to 4. The remaining 4 volt will drop across 2 ohm resistor. So option A, the voltage across 2 ohm resistor is 4 volt. Question number 9. Which circuit contains a fuse and a rectifying diode? So option D, option D, option D in circuit D, you can see a rectifying diode, then a fuse, then a resistor, and AC supply. So if you move in clockwise direction, then first encounter is rectifying diode, then fuse, then ordinary resistor, and then the AC supply. So option D, rectifying diode and fuse are in diagram D. Question number 10. The diagram shows a circuit. What is the reading on the ammeter when the switch is open and and the reading when it is closed? When the switch is open, then the current will flow through both the 3 ohm resistors, and the total resistance the current will see is 6 ohm. So I in this case is 6 volt over 6 ohm, that is 1 ampere. After closing the switch, the current will only flow through one 3 ohm resistor, and as the resistance have become half, the current will be doubled. I is equal to V over R, 6 over 3 is 2 ampere. So ammeter reading when the switch is open is 1 ampere, and when the switch is closed is 2 ampere. So it's option B. So solution is also given for you. Case 1, switch is open, total resistance is 6 ohm, V is 6 volt, and I is equal to 1 ampere, and that 1 ampere is the ammeter reading. Case 2, when switch is closed, in that case the resistance is 3 ohm and current will only flow through the left 3 ohm resistors only, and the right 3 ohm resistor will be bypassed. After closing the switch, the resistance 3 ohm resistance at the right will be bypassed, and only the current will only flow through the left 3 ohm resistor, which is close to the ammeter, and in this case the current will be doubled. So option B.